Welcome to Science Tutor. Let's draw structures of a primary alkanol. An example is the structure 2-methyl propan propan 1-ol. 2-methyl propan 1-ol. In this case, the longest chain hydrocarbon or the longest chain carbon to carbon bond is located at the probe. So we have three of it, which signifies the name from propane. So we have three. The methyl group is at the second carbon atom. The one here represents where the carbon which is attached to the hydroxyl group is situated. So how do we draw such a structure? In this case, I have propane from propan 1-ol propane. We have probe means three carbon atom attached. On this side, we also have the OH attached to the first carbon atom. That is why we have 1-ol. And then we have 2-methyl. 2-methyl simply means, and I'm counting 1, 2, it means I'm going to have a methyl group up here. That is a CH3 group. A CH3 group. This is a methyl group, a methyl group at the second carbon atom. So 1, 2, moving up, 2-methyl. Remember, each of these is bonded by hydrogen. 1, 2, 3. This is bonded by a hydrogen. This is bonded by hydrogen here, hydrogen here. 2-methyl. So in counting, we have 1, 2. So at the second carbon atom, or better still, let's move this way. We move this way, 1, 2, since we have our 1-ol here. So 1, 2. At the second carbon atom, we have a methyl group. So 2-methyl propan from propane 1, 2, 3. That is propane. So propan 1. The first carbon atom attached to the hydroxyl group, which is the functional group, 1-ol. So this gives us the structure of 2-methyl propan 1-ol. In a more complex form, we have 1, 2, 3, 3 carbon atom. So 1, 2, 3 for hydrogen. That is CH3 from here. Carbon is bonded by a hydrogen, and then on this side we have a C attached to hydrogen, where we have our 2-methyl, and then on this side we have the OH group at the first carbon atom, bonded by hydrogen up and down. So this gives us the structure 2-methyl propan 1-ol. Secondary alkanals. Let's consider an example. For secondary alkanols, they simply have two alkyl groups, arrow prime, attached to the functional group, the carbon carrying the functional group. So we shall be looking at an example. An example of a secondary alkanol is butan 2-ol. Butan 2-ol from the compound butanol, okay? Or the 2 simply represents where the carbon carrying the functional group is located. So how do we draw the structure of butan 2-ol? Now take note, we have the key man butan from butane. That means the carbon to carbon bond, the parent chain, the longest chain will carry 4 carbon atoms. That is from the word butane, from the alkane butane. The 2 is the carbon that is located to the functional group. It ought to be at the second carbon atom. But using this structure, we have our carbon. We have C. C is bonded by an alkyl group. So in this case, let's make use of the alkyl group C2H5, which is ethyl or ethyl. Up here, we have another alkyl group. In this case, let's make use of the methyl CH3. And then, remember, bottom we have hydrogen. On this side, we have the functional group, the hydroxyl group. This is a simple example of butan 2-ol. Now, how do we draw the structure? Let's consider the structure. Beginning from the central carbon, which is this. On this side, we have an ethyl group, so two other carbon atoms having 5 hydrogen. 1, 2, 3, 4, 5. So each of these represents hydrogen atom. We have hydrogen here. We have a methyl group attached to this carbon, 1, 2, 3, and 3 hydrogen. Then on this side, we have the functional group. In all, we have 4 carbon, which represents butan. Butan. So 1, 2, the second carbon simply carries the OH group. So that is where we have the 2 attached to the ol. So this is the structure of butan 2-ol, which is a secondary alkanol. In all, using the formula, we realize that we have 4 carbon atoms, C4, hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, C4, H9, and then the functional group OH. So this is from the family butanol, but where the carbon is located is at the second carbon 1, 2, second carbon atom that is attached to the hydroxyl group. As seen from here, secondary alkanols, the carbon carrying the OH group, we have an alkyl group, which is this, called ethyl or ethyl, and then we have another one at the top, which is this. This represents methyl, all attached to the carbon carrying the functional group. So this is a simple structure of butan 2-ol. On to the next, which is the tertiary alkanol. Remember, in tertiary alkanol, the carbon carrying the functional group is attached to 3 alkyl groups. In this case, R1, R prime prime, R prime prime prime. For example, let's consider the alkyl groups to be all methyl CH3, CH3, CH3. All these are different, they are all alkyl groups, but same alkyl groups, but different branches attached to the functional group. In this case, let's consider the structure. So I'm having a carbon, this is C attached to C1, 2, 3, another attached to 1, 2, 3, another down attached to 1, 2, 3. This is the functional group OH. So each of these represents hydrogen. This is a functional group. Now, in naming of this compound, we simply consider the longest chain carbon to carbon bond. In this case, we have 3. So it takes after the name propane. So pro comes into play from the word propane. 1, 2, 2, 3. So we have 2. At the second carbon atom, we have a methyl group. Still the same second carbon atom, we have the functional group. So in this case, we are also going to expect 2 methyl, 2 methyl. The functional group is at the second carbon atom attached to the functional group. That's this carbon attached to the functional group simply means 2-ol. So putting all of this together, we are going to be naming this compound as 2-methyl, 2-methyl. The family is propan. from the word propane, because we have one, two, three, propan, two, all. The two is as a result of the carbon at the second position attached to the functional group, which is the hydroxyl group. So 2-methyl propan 2-ol is simply an example of a tertiary alkanol. I'm sure we got value from this video. Please do well to like my videos, share and subscribe so more persons can see. Have a good time. Bye for now.